Salt hydrolysis. When acid reacts with a base, we know you get a salt and the water. So acid-base reaction to produce the salt and the water is what you call as a neutralization reaction. We all know it. Now what happens if the salt reacts with the water? When the salt reacts with the water, you get back those acids and the bases from which the salt was produced. So this process of the reaction of the salt with the water to get the acid and the base is called as a salt hydrolysis. So we can say that salt hydrolysis is the reverse of the neutralization reaction, because in the neutralization reaction it is acid that reacts with the base to produce salt and the water, and the salt hydrolysis here the salt reacts with the water to produce the acid and the base. Now the mixture that you get here when the salt reacts with the water and forms acid and the base, so this mixture here, the solution that you get over here can be either acidic or basic, or it can be neutral, right? The mixture after the salt hydrolysis that you get can be an acidic, basic, or it can be a neutral. It actually depends on the type of the salt, right? What type of the salt it is. So we have basically 4 different types of the salts. We have a salt of a strong acid and a strong base. We have a salt of a strong acid and a weak base, strong acid, weak acid and a strong base, and a salt of a weak acid and a weak base. Now let's take here an example of a strong acid and a strong base. For example, we have a sodium chloride, which is a salt of a strong acid and a strong base. If you do the hydrolysis here, means, for example, if the NaCl reacts with the water, what type of an acid and the base you expect? You can expect you get a sodium hydroxide ion here, and you get the hydrochloric acid, right? So this sodium hydroxide is a strong acid. It completely dissociates into Na plus and the OH negative ions, and hydrochloric acid is again a strong acid, and therefore it forms the H plus ions and the Cl negative ions. Now here in this mixture, you will see that the H plus ion concentration will be equal to the hydroxide ion concentration. So that means the solution will be neutral, right? So the solution will be neutral here. So basically the solution that you get from this hydrolysis of the strong acid and a strong base salt will be a neutral. So this reaction actually doesn't happen, this type of a reaction doesn't occur, because the acid that you get and the base that you get are further dissociated. So practically we can say that the salt of a strong acid and the strong base doesn't take place, right? So the salt of a strong acid and the strong base, it doesn't undergo the hydrolysis. So the salt simply dissociates into the ions of the sodium ions and the chloride ions. Now this reaction that I have written here over here is just to explain you, to get you a clear idea what will be the pH and how you can determine the pH. Now let's take one more example here of a strong acid and a weak base. Okay, let's see what's going to happen, what type of a pH will be there. So a strong acid and the weak base, we can take an example of ammonium chloride. This is a salt of a strong acid and a weak base. If you do the hydrolysis here, now what do you expect? You can get here the ammonium hydroxide, NH4OH, and you will get the hydrochloric acid. Now this hydrochloric acid is a strong acid. It will dissociate into H plus ions and the Cl negative ions, and the ammonium hydroxide is a weak base. It dissociates partially here into the ammonium ions and the hydroxide ions over here. Now you can see that the concentration of the H plus ions will be more than the hydroxide ions, because we have a strong acid. This one is strong acid and this one is a weak base here, right? Dissociates partially here. So the concentration of the H plus ion over here will be more than the hydroxide ion concentration. So that means the solution must be acidic. Okay, so the solution is acidic over here. So a salt of a strong acid and a weak base will be acidic here. Another salt is the salt of a weak acid and a strong base. So again we can take here an example of a weak acid and a strong base, which is sodium acetate. So acetic acid is actually the weak acid, and the sodium hydroxide will be a strong base, right? So if you take a salt of a weak acid and a strong base like this, sodium acetate, if you do the hydrolysis here, So what do you get now? You will get acetic acid, CH3COH, and you will get the sodium hydroxide here. Now you see that sodium hydroxide is a strong base, right? It will dissociate completely into Na plus in the OH negative ions, and acetic acid is a weak acid and dissociates partially, so it will form the CH3CO negative, and there will be the H plus ions. And now you can see this H plus ion concentration, if you compare it with the hydroxide ion concentration, H plus ion concentration will be less, right? This H plus ion concentration will be less, so I can say the H plus ion concentration now here will be less than the hydroxide ion concentration, so OH is more, so which means that the solution must be basic. Okay, so the solution of the the solution that you get here from the hydrolysis of a salt of a weak acid and a strong base will be basic. Now what about a salt of a weak acid and a weak base? So again, we can take an example of a ammonium acetate, the CH3COONH4 plus, right? This is a salt of a weak acid and a weak base. If you do the hydrolysis now, what you will get? You get acetic acid, CH3COH, and you get the ammonium hydroxide. Now both are weak electrolytes, so they dissociate partially. They will be in equilibrium, CH3CO negative, and there will be the hydrox, H plus ions here. And from here also you get the ammonium ions here and the hydroxide ions here. Now if you compare the H plus ions with the hydroxide ions, so here in this case the concentration of the H plus ion and the hydroxide ion concentration here, it can either be more than this one, the H plus ions will be more than the OH, or it can be less than, or very rare it can be equal also. It actually depends on the dissociation constant of the acid and the dissociation constant of the base, right? So if relatively, if the dissociation constant of the acid is more than the base, then it will be acidic, and if the dissociation constant of the base is more than the acid, then it will be basic. So it can be, now the pH can be, it can either be acidic, or it can be the basic, right? Or it can be the basic also. Hope you got it. Thanks for watching the video. Bye for now.